What the heck? Where did that text come from? That's strange. Okay. So let's see here. Testing. 1, 2, 3. Testing. Excellent. All right. Good. Okay. Let's get some music going. Hey, Freezer Cube. All right, chat. While we get, it is that time again, right? Can anyone name this song? What game is this song from? It certainly has a kind of lively and upbeat tempo, doesn't it? There's a lot of energy to this music. That's really cool, Ish. I remember my first PC build was it was really exciting up until I got finished, and it would do nothing but blue screen. That was all it would do when it turned on. I had to bring a friend over to discover that we had I plugged a socket into something incorrectly, and that was very frustrating. That computer, I think I probably messed up with my maintenance and cleaning or airflow or something, because that computer only lasted for about 2 years before it started to give me blue screens all the time. Some sort of failing component. I'm not really sure how to diagnose it right now. Yeah, I hear AMD has really been on fire lately, so it's a good time to invest in their ecosystem. All right, that's about time. For those of you who are curious, these last 2 songs have been from the indie game Freedom Planet, which is kind of it's sort of an evolution of what Sonic the Hedgehog could have gone. It has more combat. It has huge kind of treasure-style bosses. It is really, really great. And the music is too. Another reason the music is so great is because the person who made those last 2 tracks is working on my latest game. So it's very, very exciting, and she's done a fantastic job. Okay, let's go ahead and get to it. So I hope you all had a really, really nice week. I hope that Project 2, the feedback that you got, I hope it was useful. Here's a quick disclaimer, okay? Depending on the time of day, unfortunately, depending on the mood of the grader, sometimes we can come across as a little bit more harsh in our feedback than what we actually feel, particularly if we've been grading for like 2 or 3 hours straight. And that's something we try and adjust for, but sometimes it comes through, unfortunately, anyway. So don't take anything personally, right? It's always about the game. It's never about you. And try and discard, right? Mentally discard the tone at which your feedback is delivered, and just analyze it for the content. Okay, what can I change? What do players tend to be doing? What reaction are they having emotionally to different things? And remember, it's not about where you are today. It's about where you are tomorrow. And then, it's always a day away. So that's how you can keep in high spirits, keep yourself ever improving to the point where your game becomes exactly what you wanted, or at least to the point where you're very happy with it, right? This never comes fast. Okay, so let's get going. I want to add another disclaimer. I had about 2 hours of sleep last night, not because I was working late, but because I just couldn't sleep. It's very strange. So I apologize if I ramble and move a little bit slow today. So I have a few fun things for you, your inspiration for the week. If anyone has heard of the famous game Hotel Mario, Hotel Mario was an early game for the Philips CDI game console. It is unique in that Hotel Mario was one of the very few games that was, used the Mario IP, but was not made by Nintendo. Nintendo let Philips, a team at Philips, create this game for them. And it did not go very well, right? It did not go well at all, and it didn't play very well. The design had a lot of trouble. People did not enjoy this game. Fortunately, not many people owned the Philips CDI console, and Nintendo quickly learned their lesson about letting their IP just kind of loosely go to anyone. But here's something to consider. All right, that's a little bit of a downer story. The team did not have a big budget. They did not have a lot of time to work on that game, so it didn't go that well. However, someone on Reddit discovered that the lead technical artist for Luigi's Mansion 3, a critically acclaimed game, one of the most beautiful games that you can get for the Switch, I believe, worked on Hotel Mario. Right, was the art director for Hotel Mario. So look at that, right? Everyone, no matter who they are, right? Whether they're a famous game designer, whether they're just a small indie dev, whether they're a student, right? They have bad games, they have good games. The point is to keep going, right? You keep going, you keep fighting through, you try and learn as much as you can from each project, no matter if it went well or not overall, it doesn't really matter. Every project has things you can take away and fix and improve. You keep improving, and you're going to end up in a good place, okay? If you can keep that iterative cycle going. So it's very inspiring fact, right? So Yes, and if you are curious about the Nintendo games that were not made by Nintendo in the Philips CDI era, you probably want to do a quick Google search for Legend of Zelda, I think Wand of Gamelon, and what Legend of Zelda CDI will get you a nice evening worth of laughter and some very fun videos. That is the next lecture, the incomplete next lecture. So here we go. Among Us, another bit of inspiring stuff. So Among Us is a huge game right now, right? It's everywhere on Twitch. However, as it turns out, Among Us has actually, it blew up in 2020, and this YouTuber, with some pretty convincing sourcing, estimates that they've made at least $60 million, that team. This game has been around since, I think, mid-2018. Now, when it came out, it was initially a flop. Right? The game came out, and they had, I think, 20 to 40 players simultaneously for quite a while. And that's not bad, but that's not enough to keep your studio alive, right? If you're paying everyone well, and you're taking care of benefits and stuff like that. So they just kind of kept going, though. They wanted to cancel the game, but decided not to, because it did have this small, very small fan base that just kept playing. They loved the game. They were vocal about it. And so they kept adding features in their spare time. They kept updating it and fixing things. And eventually, it just caught on. The power of the gameplay, the engagingness of it, I guess, just kept people coming and sticking around and playing more. And eventually, they started getting YouTubers who had a lot of influence and audience draw. And it just snowballed. Right? So it's a really inspiring story. Some other games that came out and weren't the smash hits that they are now, Fortnite, right? Fortnite and Roblox, games that came out, I think had a decent following, but certainly not a smash hit. And then in the following years, in the case of Roblox, I think many years, just snowballed and just took over, right? And I believe Ishwar had an internship at Roblox, so he could maybe tell you more about the history of that company. But very interesting stuff. So many incredible stories happening all the time. Just got to keep our eyes open for them and try and learn from them. Okay, so I want to show you a few things related to graphics. Today we're going to be finishing up Juice. We're going to be implementing a few more things, like I'll show you how to do a quick and effective camera shake. We'll tell you how to quickly do some fun work with particles, and in particular how to get particle bursts at certain locations around your scene. And maybe we'll do something on animation curve and post-processing today. Next lecture, in a few lectures, we'll go over how to create your own shaders and write SIMD, single instruction, multiple data, right? Code on the GPU to get some interesting graphical effects. The power of shaders. Oh, this is just beautiful. Oh, yes. So this is a dev blog post that I believe shows you how to write a really beautiful watercolor shader in Unity. Step by step. It's really neat. I hope we can get an animated GIF. This person was inspired by, paintings, I believe, and I think some anime can look like this. Wow, look at that. Their 3D scene, right? You've got this really nice lighting shading going on. You got a bit of an outline shader going on. And some other effects too. It looks, oh wow, look at that. Can you see that, chat? Look at that. The textures kind of, they swish and they move and they morph in real time to give you that wow. It's like the texture's flowing. It's like it's a watercolor painting, but it's still water, right? It hasn't dried yet. That's crazy. Oh, look at that. It looks like it's on parchment. Anyway, all right, let's stop geeking out here. Okay, potential for Unity. Unity is often not regarded as the software that you want to use for beautiful, realistic games. However, it absolutely can reach that level if you want it to. It just isn't necessarily the kind of default like Unreal Engine is. Unreal Engine's default settings tend to give you a higher level of quality in the environments. This is a Unity first-person game where you're walking around an environment that looks darn realistic, right? Maybe not quite perfect. When I look at it, it seems to have a slightly fantastical look to it. Maybe that's the lighting. I'm not sure. But it looks just incredible. And you can look down at the tiles and you can see rainwater kind of splashing a little bit, not so much flowing between them. If you look at the fact that the ripples seem to just flow into the gravel here and not bounce off, that kind of breaks the illusion a bit, but it still looks incredible. Anyway, okay, government IP snafu. So as it turns out, and this is something my company does, there are a lot of big organizations out there who will pay you to, oh, it got deleted, oh no. I'll tell you the story anyway. There are a lot of big organizations, including the federal government, that will pay you to make games for them, whether those are educational games. In fact, I think they're usually educational games, or branding games. KFC made a game, right, from our first lecture. So this is a fun little example of, and you can probably Google this, a contractor for the government created an environmental protection agency game. And they used music from, I think, Yoshi's Island DS, which is a official Nintendo product. Yes, Burger King had a bunch of games, right, that were pretty hilarious. But Nintendo, no one at the agency and no one that they brought in to check this game out and verify it noticed that this sounds awfully like a Yoshi or Nintendo song, right? Or noticed it from Yoshi's Island DS. And so that is a really scary situation, right? Nintendo could have a case of IP infringement and could get a big reward if they wanted to, maybe from taking the government to court for doing this. Depending, well, okay, I'm not a lawyer, so I'm not gonna speculate, but just you got to be careful, right? So in this class, remember, you are allowed to use external assets. However, you're not allowed to use things that you don't have a license for. For instance, while you can find an image of Mario, right, really easily, you can find an image of Mario really easily online. I recommend that you cannot use any of these images in your game, okay? You do not own Mario. If you were to ask Nintendo to use Mario in your game, they would almost certainly say no. So you need to use assets that are already in the Unity Asset Store, which means, yeah, they intend for you to use them in the game if you download them. Or on a site like opengameart.org. Okay, there are a lot of sites out there that are purpose-built for helping connect you with free assets, stuff that you can just use and kind of forget about, right? Whether that's different 2D art assets, like pages and pages of them. Many of these are going to be licensed in a way that you can use them, right? OGA by, I have no idea what that license is, but you can always click on the license and it will tell you what you can and cannot do, okay? Some licenses require you to credit the person who created it. Some licenses prevent you from putting it into a commercial game for money. It has to be a free game. And other stuff like that, okay? And there are other fantastic sites like Textures, 00textures.com. Wait, CC0 Textures. Let's take a look at that. This is one, if you're trying to make a game that feels a little bit more alive and real, you're definitely going to want to look into, right? CCO Textures. So I want a wood texture, right? Because I'm building a house, right? You have all these textures, and I believe you can use essentially all of them. All right, you have permission. What on earth is that's wood? That looks that does not look like a healthy shade of bark. But I don't know that much about trees. Anyway, these textures come not only with the color textures, the color maps, the albedo maps, but they also come with stuff like bump maps, right? Reflection maps, other stuff. Stuff where it will allow you to essentially get the texture to feel like it is 3D, even though it's a 2D image. So anyway, we can talk about that stuff a little bit more later. So let's keep going. I love this Twitter thread. I hope it's not gone. This is the game development graveyard. This is a cool Twitter thread where a bunch of people posted a bunch of games that essentially never left the prototyping phase. You know how in media you'll sometimes see like evil kids take a magnifying glass? I happen to have one right here. Take a magnifying glass and use the sun to set the ants on fire or burn them, right? So this is the idea that, Spriter's resource is not something you should use because most of those assets are going to be copyrighted. You can use it for Project 1 because otherwise we can't recreate it authentically, but that's the only project we'll allow it on. So this is a game where you use the magnifying glass to set enemy troops on fire. And what's cool is that like the magnifying glass itself has a fantastic shader on it, which you're learning about how to do this stuff in a few lectures. And it distorts what you see, the image you see, through this kind of glassy area, right? Really, really cool stuff. This thing looked nice. It looks okay. What else did we get? Yeah, so just a ton of different games in this thread. I encourage you to check it out later, and you'll find some interesting prototypes, right? But the fact is, sometimes, like on your P2, as you're probably discovering, sometimes you make something and it just doesn't really work out, right? Just doesn't really work out. So you set it aside and you go experiment with something else. You find something that does work, and then you invest a lot in it. So one of the reasons that genres are so great is that if you're making, say, a tower defense game, you don't necessarily need to prototype a ton, because you know that genre is tried and true, right? If you have the elements that most tower defense games have, and if you balance them in a similar way, then you will have a game that is going to be satisfying, right? It's going to work. However, you're not going to get a whole lot of novelty off of doing that. You certainly won't excite an audience unless you add some interesting twist to it. Okay, so an important point, and then we'll end our announcements and get to it. This course is a little bit interesting in that for most of Project 1, right, for the most, for the first 30%, 40% of the course, we essentially know what you're trying to accomplish. Right, you're trying to build Zelda, you're trying to build Metroid. We know the problems you're going to run into, and we know what material to present you with, and roughly when. It's a little bit hard to get the schedule right because we're so compressed, but we know when to show something to you and what to show you. However, as soon as you get to P2 and P3, that's no longer the case. We can no longer really predict what each individual team is going to want to focus on. Some games that are going for this really rich and interactive visual style might need us to go over a SIMD and programming and GPU lecture, while a game that has simpler aesthetics might not. They might not care about that, right? So what we're going to do is we're going to, in future lectures, we're going to start branching out into a wide, diverse array of topics, okay? We'll be talking about things from, okay, you've got a 4 or 5 person team now. How do you work effectively in that team, right? What issues can you run into? We'll talk about games and education. So if you leave this university, you graduate, what can you use games for? Can you use games to help people learn? There's a lot of money in that. You very well could be doing that, right? Games as art, right? Maybe you want to go make an artistic statement, right? Or work for a company that is, or a team that is. Business, right? How can you make sure that your team, whether it's in academia, whether it is in industry, right? Whether your team's going to survive, whether it's going to be around in a few months. You can kind of tell these things by analyzing the value chain that your team is in and the ecosystem that your product or business can create, right? So we'll talk about those things in the context of video game development. So we're going to start hitting a wide variety of topics pretty soon. But we'll still be around. If you have certain things that you really want to learn about, discussion section could be really great for that. You let us know what you want to hear about. And office hours are really, really great for that too, okay? And we might have some time during the main lecture to go over some things as well. And case in point, this morning, we had a really, really fun issue in office hours where we were having a performance problem in one of the games. And one of the interesting things about this semester, we haven't gone over the Unity profiler, have we? Have we, chat? Have we gone over that? I don't think we've gone over that, have we? No, okay. So this Unity profiler is really cool. One of the things that is very, very important this semester is that normally you don't have to worry about your game's performance all that much, because chances are your game is going to run okay. Because these are simpler games, and computer hardware is very fast, right? As long as you're hitting 60 or 30 frames per second, you're going to be fine. And you can normally control the hardware that your game is on, right? During a normal in-person semester, you would bring your laptop, you'd bring your computer, desktop, to the playtesting session at Spark or at the BBB, and you would get to control like what, how well the game runs, essentially. However, this semester, you must rely on sending your game to other people, right? And you don't know what kind of laptop they're going to have. They might have a super beefy gaming PC, but they might have a lightweight kind of MacBook Air, right? And that's totally fine, but you need to be a little bit more careful with your performance this semester, okay? So one thing that you should immediately do, if you see that your game is not running very well on other people's computer in playtesting sessions or on your own even, what you should do is you should immediately look at the Unity profiler, okay? The profiler is pretty neat. Let's go ahead and get into it here. The profiler can be found on the window here, right? So you go to Window, you go to Analysis, and you go to Profiler, okay? You go to Profiler, what this will do is open up a cool little menu here, this little visualization, what happens is if you play the game, and I'll try and bring it up. Sorry. I forgot to make myself a little bit smaller. Here we go, so you can see. If you start playing the game, is it gonna maximize or, no, there we go. If you start playing your game and then you turn on this little record button here, you'll see that we've got this really cool little visualization. This shows us how much time is spent on every single frame, right? You can also see a timeline view. I prefer the hierarchy view though. Let's go back to the hierarchy. There we go. Wait, we need to pause first, sorry. But anyway, so we can see on every frame how long it took, and it'll tell us how long we need to, how short we need to keep each frame to keep ourselves under 60 FPS. For instance, we've got spikes here that are, going over 60 FPS. That's a real problem. I want to show you though, let's make a build. Whenever you profile, you should profile the build and not the actual editor, because the editor can mess up your results, because the editor can slow it down a lot. So let's go ahead and build our game really quickly. So we're going to turn this game off, and you'll get to see what we're going to build for you in just a bit. So go ahead and go to Build Settings. In order to profile our game, we need to click Development Build, and we need to turn on the Auto Connect Profiler setting. So we go to Build and Run, go to create our game, and we'll wait for a second. It shouldn't take very long. How's everyone feeling, chat? By the way, you're in P2 now. How does your energy, how does your sleep schedule compare to P1 while we wait for this to start up? Are you feeling better? A little bit better, chat? Yeah? No? Much better. Freezer Group said, wow, it's just unanimous, it seems. So much better, right? Yeah, I really do wish we had a better way to ramp you up. In fact, okay, I'll be honest, I wish we had another course. I wish we had another course so that we could kind of ease you into game development, get you familiar with Unity, and then hit it hard in the MDE. But unfortunately, we wouldn't have enough people for the MDE if we had a prereq of taking a previous course. So it's a little bit of a mess. It's a messy situation. But anyway, okay, we got our game running, and if you look at this, you might notice that, wow, this looks kind of laggy. This looks kind of laggy, doesn't it? It doesn't look very good. It doesn't feel very good to play. And so what we're going to do is we're actually going to look at our Unity profiler to see what's going on, because while the game is running, we can go from play mode to the Windows player. We can turn this on. Oh, sometimes you have to turn it on and off a little bit to get it coming in. Here we go. We got the data coming in. Ooh, that's nasty, right? That is not so great, right? We are spending over 66 milliseconds per second in this game, and that's causing us to play like a slideshow. We're only getting 15 frames per second. That's less than a movie at 24, right? So that's not great. And so what we need to do is we can turn it off, and we can click on any frame, and we can go through this hierarchy to see exactly how much time is being spent by each function in our project. So we can see that, there's this, update.script_run_behavior_update is taking 95% of our time, 91 milliseconds on this frame, right? Okay, so we're going to go ahead and we can drill down. So behavior update. So it's in one of our update functions, okay? And look at this. We've got this function called suspiciouslogic.update, okay? And it's taking most of the time. This looks like a really inefficient function. I'm very suspicious of it, right? It's generating 6.3 megabytes of garbage per frame. Multiply that by 60, you'll get the amount per second. 91.2 milliseconds, right? That is, yeah, that's a little bit suspicious for sure. So let's find this function in our code base, suspicious logic. Oh, you know what? I think, I'm thinking that suspicious game object over here might be to blame. And it has suspicious logic on it, right? So that's the component that we need. We could have just searched for it down here. Let's drill down. And we know it's going to be in the update function. Aha, look at that. Okay, so there's some code in our suspicious logic component that only runs if we are not in the Unity editor, right? This is called a pre-compiler directive. Essentially, you can turn code on and off. You can include it in the game or exclude it based on certain things. For instance, if you're in the Unity editor or not. It's kind of like a macro. Anyway, so getInspiredMessage is a function that we print, and getInspiredMessage returns an inspiring message. Welcome to Great Day number. But it goes through 50,000 iterations of essentially generating different messages. Welcome to Great Day number 1 through 10,000, or 0 through 10,000. It then returns the result after finding 50,000 messages, and there you go. We do this every single frame. So this is, yeah, it's a bit of an issue, huh? So you know what we're gonna do? It's gonna, there we go, done, right? And we'll compare the results, right? So improving your performance is just very iterative, like many things in this course and many things in life, right? You make a small change and then you test it out. So we're gonna go ahead and make another build with our fixed component. We're gonna create another build here, get that going. We're gonna kill our current running build, otherwise it'll complain to us. Then we'll check out the performance again, and we'll make sure that suspicious function isn't consuming all of our time, okay? So, yeah. So this is to say that, so unfortunately this is kind of a hacky example. I didn't have a game ready that was suffering from performance issues. Fortunately, but unfortunately. Hey, and wow, is that smooth or what? That looks beautiful. And let's go back to our Unity editor and just confirm with the, look at the data. So we'll start that, and then we'll go here. Okay, there we go. We're recording. Look at that. That looks a lot better, doesn't it? But still not perfect, actually. Not perfect. So there's some optimization we could do. I don't like, oh, why is it still going? Here we go. What's up with this frame? I'm curious. Early update, pull player connection. So I'm not sure. I think that's just a result of us clicking the deep profiling. So if you create a development build, it will run slower than a non-development build because it includes a lot of additional logic that allows it to send you this data, for instance, and detect exceptions and stuff and output that to console. So anyway, this is what I recommend. And you know what we also might be able to do? Yes. All right. So you can actually, if you create a development build, you can even connect your console to the game, the actual build that's running. So if you have issues with your build and you want to debug it a bit, you can use the console to get messages from your build while it's running. That might help you out quite a bit, okay? So anyway, it's extremely addictive to iterate and try and improve performance. So keep an eye on it, okay? Don't prematurely optimize. It has been said, right? One of the famous phrase, premature optimization is the root of all evil. And what it's saying is that many times in order to make something fast, we have to program it in an unintuitive way. And this can cause your performance in-game to increase, but it can cause your dev time performance, right? The rate at which you add new features and fix bugs to decrease. So focus on your dev time performance until your runtime performance is clearly an issue, okay? All right. So can you only connect a build to console? Yeah, I think only development builds give you that functionality, right? Because players, if you sent this build to a player, they would have no use for that. So got to get rid of any functionality that could slow it down. So when you look at this cool little prototype right here, we got a few things going on, right? We had some basic particle system, so like snowflakes happening last time. You can watch the previous video recording to see us do that. However, and we also had the balls that would they'd shake and get squishy when they hit something, right? However, there are a few things in this particular shot that we don't have. For instance, when the ball hits the wall, it actually generates particles that go flying right at the point of collision, and it looks really cool. These particles that come out, also they come out as like these red hot particles, but then they cool down, then they go to yellow, and then they go to white before fading out to full alpha, right? Or zero alpha, sorry. There's also another thing. When the ball hits the wall, we get the screen shake effect where the camera's like, right? Almost like a spring, right? And we also have a cool effect here that might remind you of the Elder Scrolls Oblivion, right? We've got this bloom, right, where these bright white spheres actually have light bleed off of them. So it creates this kind of, I don't know, it's a unique kind of shiny. It's kind of Vaseline shiny, as if you put a little bit of some sort of oil on the screen, right, causing the light to scatter. Anyway, so the question is, how can we build a few of these things? I want to show you how to do that today, because it's pretty darn fun. Let me show you a few examples of what I'm talking about first, though, because I think I put some in here. What's the first thing we want to do? The first thing we should do, let's do particles, okay? And I hope I don't mess this up. The particle system isn't something I use a lot, but it is pretty fun. Here we go. I have a little horror game that you can play. Actually, Ish, can you post this URL? I'm just going to type it in. It's not that hard. You can all play this. It's a horror game, okay? So, trigger warning. It's a super spooky game. The graphics are so real. You won't believe it. The gore is so realistic. It is truly something else. I might get in trouble for even showing this, to be honest with you. So I think that link will probably work. Let's jump in here. It is a Resident Evil. Oh, I have to play this in Chrome because it just doesn't load in Firefox. I'm not sure why. It was a prototype, so I didn't care that much. Let's create another window here. Let's go to Google. Okay, so here we go. There we go. All right. Boop, 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 boop. Da, da, da. Chrome is scary. Okay, so this is like a lo-fi Resident Evil clone I made in like a day. And you can go grab a weapon here with the left click, and then you got some zombies coming. Oh, geez, it just dived at me. Okay, so we're not going to need to shoot that zombie. Oh, I'm dead. That was not a very good demonstration. Let's go ahead and turn around, and we're going to grab our pistol again. We're going to turn around and get some zombies to take care of. Where are they? There we go. And you can hold the... Oh, I lost my audio. That's a bummer. But you can hold the right arrow button, the right mouse, and you can left click to shoot. And if you hit a zombie, you'll know because it generates these kind of spots of blood, these bursts of blood, right where the collision happens, and then it has a leak that occurs later. If you miss and hit a wall, you'll get these sparks, which look pretty cool, where the bullet hit the wall. And we can see that probably better if we come over here. And if this is really hard to control, here we go. These are using tank controls. This is how old school horror games used to control and how the camera systems used to work. Anyway, so you can see that particles can really make you feel like, hey, I'm actually shooting a bullet. So anyway, let's keep going. So how can we get that kind of effect? Well, we know how to make particles appear somewhere, right? So let's go ahead and first of all, let's turn off the particle system. We're going to recreate it, okay? Let's go to our impact sphere, which is what requests our particle system manager to spawn some particles at a position, right? Let's go ahead and get rid of that. Let's create a new particle manager, and let's get a little bit crazy. We're going to call this particle manager. Particle manager, or particle system manager? Let's just call it particle manager 2, okay? And this is going to have a particle system on it. Okay, so now we have these kind of, these shaderless, these materialless rectangles flying everywhere. Okay, so that's not really what we want. Let's go to the render, fix this. We need to give it a material. What material should we give it? Let's give it a default particle. That's fine. All right. Okay, I just like these better. I really like the pixels. Okay, so let's go ahead, and I don't want this to come out in a cone. So one thing that we can do is we can come up and find the shape here, and it has a bunch of different shapes that we can configure. Let's go to sphere. It is now coming out in this kind of spherical shape. That might not be super obvious because not enough are coming out at once, and they're coming out too slowly. Let's increase the speed. So we got the speed going out a little. Okay, that's not enough. Let's go to, oh, there we go, 50. Okay. However, let's make the lifetime shorter because they're getting too far away. So now it's just kind of going out a little bit, and we don't have enough of them. So let's go to emission and increase it to 100. Okay, that looks pretty cool. Obviously, we have to send it even further. Wow, that looks really, really cool. Okay, so we don't want these particles to just come out and just fly out. We want there to be some, they're realistic particles, right? They should have gravity. Well, that's something we can turn on. I believe gravity is set to 0. Gravity modifier, is that it? Is that it? Oh, yeah, there we go. If we make it heavier, I think we'll see that they kind of fall more. Wait a second. No, that's wrong thing. Let's go to here. There we go. So we got this little fountain down, right? This is going too fast, I think. There we go. That's much better. Okay. So we've got these particles, and now they're falling, right? One thing you'll notice is that if we move this particle manager object around, it's like super stiff, right? We want this particle manager game object to create particles that kind of can float around and be carried by the wind and gravity. And if we move the system, we want to like sprinkle particles everywhere, not make them all move themselves. In other words, all the particles are parented to our game object right now. And that's not what we want. So what we'll do is we'll go down and we'll say the simulation space for this batch of particles is going to be not local, as in parented, but world, okay? So what happens is when we move this around, ooh, we got this nice little spray effect, right? Where we're actually spawning the particles in, and then they simulate on their own, not parented to anything. Okay, well that's cool and all, but we want the ability to burst these. Now this is the thing I always get confused by. We don't want it to... You know what? I take that back. We don't care about that. We can fix that later. Here's something though. These particles really just have the wrong color, okay? They're not giving me... okay, so how could it calculate so many particles in real time? So when it comes to particle systems, I've never created one myself. However, particles are fairly simple to manage in that when you have one particle, it tends to work very similarly to all the other particles. One thing that's really great about this, when you have that kind of standardization, it allows you to use a technique called data-oriented programming. Essentially, it is the idea that we're going to take all these very similar particles, we're going to make sure that their unique data is kind of co-allocated in memory, right? Each particle is going to be put in contiguous memory right next to the other particles so that when your CPU goes to grab one particle so it can do its operation, the cache, right? It will grab the next 100 particles, right? So one kind of memory hit is going to get you not one particle but 100, and that allows it to scale super well. And one operation on a particle can affect and do the calculation for like 100. There are a bunch of unique CPU instructions that can help you do this. By the way, this is also something we'll talk about next time with SIMD, right? Single instruction, multiple data. It's the idea that you want to execute one instruction on your CPU, but you want this instruction to affect many different parts of data. And that can get you massive efficiency and massive parallelism. It's really cool. Anyway, so that is a very high level, and I'm not an expert on low-level systems, but that is essentially how it works. Okay, so we want to adjust the color, right? And not only that, but we want the color to be affected over the lifetime of this particle. Right? We want to start off as this bright red, to show the fire and energy of the friction. And then we want it to kind of cool down and then fade away, right? Going from red to orange, yellow, white, okay? Well, up here we can control the start color pretty easily, right? We can make it a red fountain if we want to. We can make it a bit of water here, right? If we want to be a blue fountain. However, we'll start it off as white, and we won't use the starting color because we don't really care about that. We want color over time. And if we look, this is one of the options that we have. So color over lifetime. We'll turn that on, and we'll actually open it up, and we'll look at it. If you click on the color, you'll see this really cool little editor comes up that allows you to establish essentially a gradient of different values. So on the top here, we have alpha, right? We want the particles to start fully bright, right? Fully visible, not transparent at all. And at the end, though, we want them to be invisible. And look at that. Now, these particles become invisible as time goes on, right? Look at, wow, that looks really cool. I love that. So let's keep going because we don't want to just affect alpha. We want to affect, and by the way, we don't want the alpha to be fully gone until toward the end. So we'll add a new node here. And we will say, hey, the alpha is going to stay at 100 until really toward the end. Uh-oh, that didn't work. Hold on. Bring it all the way up here. There we go. When you have a ton of particles, it lags a lot whenever you do something. Let's reduce the number of particles for now as we experiment. Let's go to 100. There we go. Okay. So now we've got our color, and they are disappearing at the end, so that looks pretty good. Let's actually adjust not the alpha, but the color. So it starts white, it ends white. Let's go ahead and change this. We want to end at, we want to start at red. We want to end at white, right? Ooh, that looks pretty neat, right? And it gets into this pink kind of color. However, let's go ahead and instead of heading to pink, we'll kind of cut it off, we'll intercept it, and we'll get a nice orange going on, right? Oh, that looks pretty sweet, doesn't it? Right? The very top of this fountain, this almost looks like, this reminds me of fruit punch a little bit, maybe. I'm not sure why. But let's go ahead and bring this over. So more of it is more red at the beginning, right? And it goes to yellow and orange, and then it goes to white at the very end. That looks pretty darn cool. This could be a volcano, actually. So anyway, if we take this over to where our actual balls will be hitting the wall, it is way too big, right? Look at that. These particles are really neat, but they're way too big. It's just going to show up, and it's going to, it's going to look like that. Yeah, that doesn't look good. It's way too big, so let's make it smaller, right? The size is not going to change over the lifetime of the object. We could make it so, but we don't need to do that. So let's go ahead and set the start size to not 1, but 0.1. Yeah, that doesn't look great. That looks like someone's being attacked right there. I'm not a huge fan of that. So let's go ahead and make it a little bit bigger. And we're going to make it a little bit less speed, I think. Let's make the gravity a little bit less. And we'll make the speed a little bit less. Maybe. Okay. That looks pretty cool. That looks pretty cool. Also, you notice the particles aren't starting at the very center, which doesn't make a lot of sense. They're kind of all appearing when they spawn in this sphere area. So we can actually fix this by going to the radius property and setting it to something like 0.2. Now they'll spawn at the point of the particle manager, wherever it is. However, they'll spawn within a 0.2 radius of that. So that looks pretty good. And now, though, it doesn't look great, though, because the particles are going through our little platform here. So let's go ahead and give these particles collision. So we'll open up collision here, we'll turn it on, and you need to always remember to set it not to the plane, but to the world, okay? So now you can see our particles are actually bouncing off the ground here. I don't know if I want that much bounce. That's a lot of bounce going on. If we take it to the extreme and get rid of no bounce, then it just kind of hits the ground, suctions onto it. That doesn't look super realistic either. So we'll do something in the middle, give a little bit of bounce going on. Yeah, you got a little bit of bounce, a little bit subtle. We'll get a little bit more, right? And so, yeah, it's starting to look okay. So now the question is, how do we get this to actually move and be where we want it to be, and just do a little puff instead of always being the volcano here, ever spawning. So what we can do, and actually let's move this over because I'm wondering how this is going to look when it's very near the wall. Yeah, I think that's probably fine. So what we can do is we can take this particle manager. I think we can tell it to not play, right? Can we tell it to not play? Can we tell it to stop? We can definitely do it through code. I'm not sure if we can do it. I'm not sure if we can do it in the editor here. So let's. Oh, play on awake. Does that change it? No. All right. Well, when the game starts, it won't play. So let's go ahead and we will turn this particle manager off for now. And what we want to do is essentially when we want to have a system that allows anything in our code base to say, hey, particle manager, generate some particles for me at this location, okay? And for this amount of time. So we now have an API. Any part of our code base should be able to say, hey, particle manager, please, generate a poof here, right? And maybe we could do something that is a little bit more decoupled. For instance, we could have a particle watch system that intercepts certain events, like the ball collision event, and then tells the particle system, its friend, to generate some particles there, right? That way, the particle watcher and the particle system would only be coupled to each other and nothing else in the entire game. And no other system would be coupled to the particle manager. But let's just do it the straightforward way for this example. We don't want to be here all day. So let's call this the particle manager 2. And we're going to use the singleton pattern to make sure there's only ever one of these and that it is super accessible. So we'll go ahead and launch back into it. Show me the code. Come on. All right, there we go. So what we'll do is when the game starts and we want the earliest possible time to establish our singleton, we'll create a static particle manager 2. We'll call it instance. There we go. So we'll check first, hey, is there already one of these? So if instance is not equal to null and instance is not equal to us, what we'll do is we'll say, hey, there's already some, we already exist, so we got to destroy ourselves and go away, right? Otherwise, we're going to go ahead and jump into that variable here, claim it as our own. So instance equals this, and then we want to make sure we don't get destroyed if we change the scene, okay? So there we go. We got our singleton established, and now we can start creating our APIs. So we can go public static void request burst. Let's go ahead and say, hey, where do you want to put this burst? So position, and then we want to say, hey, how long do you want to have it, right? Duration, seconds. Okay, so now we've got our cool little API. Should be pretty easy to use, unlikely to be used in the wrong way, which is good. What we'll do is we need to actually manipulate our particle manager. First thing we need to do is we need to actually take our instance, and hopefully, one way this API could be messed up is if the instance doesn't exist yet. For instance, if some other system requests the particle manager in their awake function, and their awake function happens to run before the awake function of particle manager 2, then we might have this issue. So we need to do a quick check. If instance is equal to null, then we need to go ahead and just return. We could also put an error message in here, like, hey, debug.log error, and I always like to put what component this is coming from, particle manager 2, though it's pretty obvious from the log automatically. Hey, use this a frame later, please, as we need one frame to initialize this system. There are some other patterns you can use to get away from this. For instance, we could run this initialization code in the request burst function if this instance is equal to null. That would guarantee that the first time anyone uses this function, this instance in the system would be set up. But let's not use that here. It's kind of annoying. And then we need to return because we can't actually execute if we don't have our particle system game object spawned in yet. So what we'll do is we'll go instance.transform.position, and we're going to set that position to where we want to be, right? So the particles will appear where this game object with the particle system component is. So we need to move it to where we need to be, and then we need to tell it to play. Okay, so let's test this real quick. When we start the game, it shouldn't show anything because it shouldn't be playing when we start, right? Play on awake is turned off. So let's go ahead and start the game. Yep, looks fine. All right, so there are no particles anywhere. Well, no particles from our actual system here when the ball hits the wall. So what we need to do is we need to turn our particle system on, but to do that we need a reference to it first. So let's go ahead and in the actual instance variable, in the actual non-static instance of the class here, in the singleton, what we'll do is we'll go, hey, particle system, we'll just call it PM, and we'll grab and fill that reference when we instantiate the system, when we launch it. So we'll go get component, particle system, and there we go. We should be able to use PM now if our instance is not null. So we can go instance.pm.play. Play. And we can tell it to start playing, and we need to somehow tell it to only play for some amount of time. But let's go ahead and let's try this right now, okay? I want to see how this looks. So hopefully, actually we're not even calling that function though. We need to actually use it and call it. And this starts with it turned off. Let's actually make sure it's turned on first. Okay, that should be fine. When our spheres hit the wall, they need to call and use our API. So particle manager 2.request burst. The particle system then will fulfill our request. Where do we want to put it? How about at the collision dot contacts, and we'll get the first contact. We could be contacting at multiple points in our collision, and yeah, we need to get the actual point here. So there we go. Yeah, there we are. So let's see how this looks, because I'm worried that we're going to put the particle system into the wall, which means we'll see no particles at all. We also need to give it a time, even though that parameter is currently irrelevant. So let's go for 1 second. It's not going to look good. It should probably be more like, okay, let's make it 0.25, okay? These testing parameters, too unrealistic. But we'll certainly notice if it works, though. Okay. Doink. Hey, that looked all right, didn't it? Boink, boink. I like it. Cool. So that worked pretty well. However, it is continuously just putting out particles, and that doesn't really work very well. So this system needs to keep track of another variable. Okay, we'll make this a variable of the instance, the singleton itself. We'll make this just particle. Let's call this the play duration timer, and it is in seconds. Okay, it starts off at 0.0, so because we shouldn't be playing anything. When we do a request, we will set this variable to whatever our duration seconds is, and we will constantly, in the update function of the singleton, we will constantly, we're not going to use a coroutine, and we definitely could do that, so that would be a pretty effective way to go. We're just going to do this, time.delta time. Time.delta time is the amount of time that has passed this frame. So usually that is, 1/60th of a second. And so what'll happen is if we set this to 0.25 or whatever it is, we should expect this variable to stay above 0 for essentially that amount of time, around, unless we're lagging or something. And even then, it should probably still take about that much time. So if play duration timer is smaller than or equal to 0, and we're currently playing, so our particle system, why did I call this PM? Why did I call this PM, everyone? This is the particle system, so this should be called PS, not PM. Okay, so we refactor, right? Make it easier for our teammates to understand what's going on. Is playing. So if we are currently playing, then what we'll do is we'll say, hey, stop. Nope. There we go. Cool. All right. It's pretty simple system to implement, but simple systems are the best. If you can find a nice way to implement something, then that is golden. Doink, doink. Oh yeah, look at that. That looks great. Oh, I love it. Let's make it a little bit smaller. Let's make it a little bit less time. Let's just about 1/10 of a second, right? Just so it's clearly only happening at the impact. Because I really like Project M. No, I don't. I've never played it. Same question. Okay, we got some questions. The system can only spawn particles in one location at a time, right? That is correct. So that's actually a weakness of this current implementation. Here's a way that you might solve it, though. You might have a pool of the project manager game objects, particle system game objects. And what you do is when a request comes in, if another particle system isn't playing, you iterate through your list, or you have a list of particle systems that currently aren't in use, you grab one, move it to the right place, turn it on. If you don't have enough particle systems for all the requests coming in, you create a new one, right? Instantiate the prefab, get it running, get it to the right place, and tell it to play. Add it to your list so that you can use it later if another request comes in. That is how I would do it. So that would be a more sophisticated system. However, for a simple game, this kind of approach probably works pretty well. Okay? You might notice if there's a lot of stuff going on, you might notice there's not. Well, actually, you know what? Let's test it. I'm kind of curious. This spawner is spawning stuff every 3 seconds, huh? Let's make this a little bit more exciting. No, not good enough. Right? Okay, there you go. So the next thing that I want to show you how to do, and then we'll take a quick break, is I want to show you how to do this nice kind of camera motion, okay? So last time we talked about a technique you can use where an object is invisible, but there's another game object that represents it visually and follows it around, right? It's kind of the model view controller pattern, but with no controller, and it's just your model, the actual state of the game, and then a view game object that shows off that other object, right? Separating the visuals of a game object from the physics and gameplay logic of that object is a really, really useful thing to do in many cases. This is another interesting case where we want our camera to be able to move around and shake at the same time, right? So let's go ahead and just create a new, let's create a new camera, okay? We've got a camera here. So we'll go to camera. We got a camera. Okay, cool. All right, and we'll move it around a little bit. We'll get rid of the hideous background. Yeah, there we go. Nice. Okay, and there we go. We've got another camera, and it should look okay if we start the game. Hopefully. Yep, looks fine. Uh-oh. Oh, we need to get rid of this this function here. Okay. All right. So, does not achieve the same thing. You could turn off looping. You could turn off looping if you wanted to, but you need the system to turn off the playing. You need to call the stop function eventually in your particle system. Turning off looping, I don't think would change much for us. So anyway, we want to implement a camera that will shake when we have some sort of impact. Okay. And we'll have another simple API for that. So we've got our camera, and we will call this the camera shake manager, right? And there we go. We've got our camera shake manager, and we'll keep it simple since I want to get to our break. So we have this camera shake manager. The first thing we probably want to think about is what is our API, right? So it's going to be super ultra simple. Public static void request shake. And okay, is there any I guess you could provide how long you want it to shake, but we'll just make it a very simple API. So someone requests shake and you do a little shake, right? And so what does that mean? Well, we need to have our game object, our camera, move, right? Bounce. So we need to establish the singleton pattern again, since we're only going to have one camera that we want to shake. So we'll keep it simple. We'll have an awake. We'll have our singleton static camera shake manager instance. Let's go ahead and set this up. So if instance is not equal to null and instance is not equal to us, then we're going to go ahead and destroy us and we're going to go ahead and return. Boom. Otherwise, we need to fill that instance. We'll claim it as our own. Equals this, and don't destroy. Great. Okay, done. We want this instance, this camera, to like move around, okay? And we want it to kind of move around in an organic way. If you look at the movement of the camera in our example there, it actually moves in a really kind of springy way. And so, you know, we can use the spring function. We can use Hooke's law again to get that done, right? So let's go ahead and get our update function going. So we'll calculate how we want to move every frame. So we'll calculate our displacement. And that's going to be, what is that? That's going to be negative, no, that's going to be the distance of the camera from where we want it to be, right? So vector3.0 is where we want it to be, right? And there's actually going to be a bug in this program I'm going to write, so keep an eye out for it, okay? So vector3.0 minus where we currently are. So transform.position. This is our displacement. We want to be at 0. We're currently at transform.position instead. Then we need to calculate our actual acceleration, which I believe it ends up being, if I recall, acceleration is equal to, what is it, negative kx? So some value k, and we'll put it here, public float k equals, what was it last time, like 0.3 that was worked well? K times our displacement, okay? And then acceleration is going to be a change in our velocity. Since we're moving through 3D space, we'll use vector 3 to represent our velocity. And we'll set this to 0. Okay, so velocity is change in acceleration. So velocity will be added to by a times vector 3. Actually, acceleration needs to be a float vector 3 too, doesn't it? So vector 3 acceleration. That means displacement needs to be a vector 3 too. So vector 3 displacement, there we go. Should be fine. And then we need to have a dampening factor. So multiply by some sort of dampening factor here. Public float 0.99. It's going to be really springy at first. We'll probably tune it down. Okay. We need to then use our vector does not equal float. Where are you seeing that? So we need to actually use our velocity vector. So we'll go transform.position plus equals velocity. Okay. So I probably forgot something. I'm kind of tired. But let's see what happens. Going. Oh, we need a way to perturb it so we can test it. So we'll put some little testing logic in here. If input.getKeyDown, key code .space, we'll go ahead and we'll do a request of the shake, which is going to go ahead and take this instance. It's just going to simply perturb it, right? Transform.position equals unityengine.random.onUnitSphere, okay? So it'll perturb it, how about by 2, okay? So that's a pretty big amount of motion. We should definitely see the shake if it's working. Okay, so we're going to play the game and something's going to go bad. Will it be the right thing that goes bad? Whoa! Oh my goodness. Let's go ahead. We're shaking a lot, so let's go ahead and make this something like 9. We're going to press space, and look at that. It's really stiff, though. Also, you might notice we are inside of something. Oh, that's much better. I like that a lot more. 0.5. Boing, boing, boing. It's just perturbing too much. So 0.05 and 0.9. That looks really good. So it should be change and fixed update. Not really. That's not super important for this. So let's go ahead and look at what's actually happening when we perturb. So we'll drag our scene over here so we can see. Now what's happening is this camera is actually working really well, right? It's bouncing like we want it to, but it's always in the wrong place. We want it to be over here, right? Oh, and that's so much fun. We can drag it over like that. That could be a cool game mechanic, actually. However, we want it to actually be over here. The problem is with our current code, even though it's easy to understand, right? It doesn't work. It only works and it assumes that you want the origin to be at 0, okay? And that's just not right. So what we can do is we want to take this camera and we want it to be inside of something else. We want it to be housed inside of an actual kind of mantle where you can actually move that around and have the camera bounce inside of it. That's going to allow us to use the simple code that we've written, essentially exactly how we currently have it. We're going to create something called the camera container. Okay? And we're going to move the camera inside of the camera container, and then we'll, of course, make sure it's in the right spot. That causes the camera to move, right? Okay, so our camera container is way down here now. Let's bring it back up and make sure that the player can see the game. So there we are, our camera container. It's right in the center of a piece of block. So we'll bring it up. Okay. So by doing this, what we've done is we've separated the position and the rotation of the camera from the kind of internal shaking of the camera. So the camera could now shake once we change this code up while we move it around. Let's take a look at this code. We can no longer use the absolute position of the camera object because it is, that's just not working. We need to use the local position, okay? If you look at the transform component of the camera, it's showing you the local position, right, at 0, 0, 0, not the absolute position. We drag it out and it'll show the absolute position, which we don't want to affect at all, okay? So what we'll do is we'll say, hey, transform.position, nah, let's do local position instead, okay? And we can just actually do a quick search for this. Oh, it's right there, and it's right there. And is that it? Is that it? Do a little search. Boom, 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 boom. Yeah, we're good. All right, good. Okay, so let's go ahead and try this and make sure it's going to work for us, okay? And so what we expect to happen is we expect to be able to move and position our camera while shaking it, and it should work just fine, right? So we bounce around a little bit. That looks good. We can move it around, and I'm moving the actual camera internally, not the camera container. See, we can move the container around just fine, very easily, but the camera can shake inside of it while we do this, right? So it works really, really, really well. And now all we have to do is we just need to have the rest of our code use that API. So it's no longer just a dummy piece of code running this, querying the system, and we'll make it a little bit smaller. It is now the actual game itself using the system. So we'll go, what was it? Camera shake manager dot request shake. Okay. Let's go. Come on. Hey. All right. Good. Okay. So hopefully it'll work, and we'll have essentially the functionality that we had earlier in the day, right? All right. There we go. Looks pretty good. So again, this is something that you can build really fast. You can build these simple systems that have a big impact on your game very fast if you've got a little bit of experience with it, and if you don't explain, on a video what's going on. Okay, but in general, keep your systems simple, mainly so that you can super quickly debug them when they start showing you bad behavior. Okay, you can find out what's going, you understand it really quickly. Oh, this is happening. Okay, I need to do this, right? And that helps you build systems that work much faster. Okay, so let me know. I have a feeling you have questions. We're going to take a break, okay? Take a little break, and then we'll go into post-processing, and I'll show you what that's all about, okay? But we will see you in about 5 minutes. I'll turn the music back on. Chat, I have a feeling you have some questions. Ishwar has been answering some of them, I believe, but I will answer them too, okay? So 5 minutes. We'll see you in 5. Chat, let me know your questions, okay? On any topic. We gotta find some music first here. Oh, what's a good one? We need a good one. No. I'm getting stumped here. Here we go. I don't see any questions, chat. I just refreshed the chat, so if you did post some, post them again so I can see them. Okay. Do 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 da. I'm glad most of us are feeling a bit better. It is definitely a struggle, right? P1 is a struggle that I think is very easy to understand, right? You have a big ramp up when you need to move fast so that you can do interesting things. You know, you get to P2, you get to P3, and it becomes a lot more, you own the struggle a bit, right? So you kind of decide to a certain extent if you want to build that interesting new feature, if it's necessary, if you want to experiment with it, if you want to skip it. You can make a pretty excellent game if you iterate, you know, you do regular iteration but not a ton of it, then you listen to the feedback you get from your instructors and peers every week. You can come out with a pretty good P3 game, gonna get you that A, without putting in too many hours, staying pretty healthy, which is good. But I know a lot of teams that are really, they want to work in the game industry, they want to have that really cool final portfolio piece as they graduate. A lot of teams really enjoy that P3 experience, and they go maybe a bit overboard, but I'll tell you, you learn fast. You learn fast, and this is the time to do it. I'll tell you, right? Gosh, I think most of you are in your early 20s. I will tell you, as soon as I hit 24, it was like a switch happened, and suddenly I just can't tolerate missing sleep like I used to. It is just so hard. It was really sad. Anyway, are all of these demos actual Unity projects we can look at? Yes. So this is the course code repository. And the project that we just showed you, right, with the balls hitting the wall, are I should come up with a fun name for that, more than Juice Workshop. But it's right here, right? It's right here. And if you go to the Canvas, if you go to Canvas, you can find our course repository, an example repository right here. You can download all of these. You can use them in your game. If you want to get the pub sub code, it's right here. If you want to get the juice code you see today, it's right here. There are a lot of other things too. There's even an example of how to do composition in C++ that I created for my job interview. It's not written very well and it's not very performant, but it does work, and it is the composition pattern. And there's other stuff you can look at too. So I encourage you to do so if you're bored, if you want to quickly get the stuff into your project so you can poke and prod it and tweak it and balance it. That's the easiest way to learn. You know, you take something that exists, you kind of dissect it like a frog. Unlike dissecting the frog, it doesn't die. But it's a really, really great way to learn. I encourage it. Just please use it so that effort didn't go to waste, you know? Yeah. Glad my internet cut out right as I asked that question. I forgot to end my sprint for P2 Gold Spike, so in the reports the end date is October 11th. Will it be an issue? Potentially. So the way that your project management grades your project management sites are graded is the instructor has a bunch of things to look for, and one of them is that you've configured your start and end dates for your sprints correctly. The good news is that one issue never adjusts your grade downward. So you can mess up one like category of thing, whether that be, you know, not assigning your tasks to someone, right? Which doesn't matter for P2, but on P3 and P1 it does. It can be, you know, you scrambled to put in all of your information at the last moment, so your burn down chart is very obviously, you know, scrambled or maybe even fake. So you can mess up one category of thing before getting moved to the middle column, and then if you mess up multiple things, you have a potential of getting knocked to the final column, 5 out of 15. That's how it works. So you should be fine if that's the only mistake you've made. But really, you do need to be checking in with, you should be checking in essentially every day or every other day with your project management. Otherwise, what's the point, right? It is meant to help you understand what is on your plate, what you've thought about, the time estimates, how much time do you think you need for all this stuff. And the more you estimate, the better you get at it. And on a team-based project, it's going to help you understand what everyone else is working on, right? So it's going to keep you more efficient that way, keep you from stepping on each other's toes, building the same thing across multiple people. That's never great, unless you're pair programming. You can, so you don't need to credit the external repo. You don't need to credit us. You can if you want to, but we assume that you're using some amount of the code in this course. Is it fine to edit remaining time that doesn't correspond to work logged if we realize something is going to take shorter or longer after we start working on it? You can edit the length of your tasks if you want. That's fine. I don't think that will mess with your burn down chart. However, I recommend that you don't do that. I recommend that you log the time, and then when you're done with something, you just move it over to done. And the reason is you want that kind of historical record of, I thought this task would take this much time, but it actually took this much time before it got to the done column. Because you can look back and you can use that history to kind of help estimate what future tasks, how long they're going to take. You can be more accurate, and that'll help you allocate your time better. So my sprint did have the proper start and end date time, but the point of having the start and end date set up if you have to manually start and end it. Is there any way to set up? Yeah. Oh yeah. Yeah. You can. I'm pretty sure you can set up a sprint so that it has a defined start and ending date. I think that if you go to, I think a dialog comes up when you create the sprint that allows you to say when it's going to end, right? Yeah, I'll look at that later, but I'm pretty sure you can do it. And if not that way, I imagine a quick Google search would bring up how to do that. Okay. Yeah, otherwise, if you can't do that, the burn down chart's not going to make a whole lot of sense when you look at it. Yeah, okay, so yeah, that is a problem if it looks like a horizontal line, but chances are you're just not looking at the chart correctly. We had an issue in office hours like this today. Let me show you all what you should do. Okay, unfortunately, I'm going to have to anonymize this because I can't show you someone else's burn down chart. At least I don't want to. Keep that kind of private. Okay. Okay, so I'll take a screenshot that you can see, okay? If you see a burn down chart that looks like this. If you see a burn down chart that looks like this in your report, you really need to look up at the top of this screen and see if you are in the sprint report, okay? The sprint report looks like this, right? You'll see this, okay? If you see that, you don't want to do it. You want to click on switch report and you want to go to the burn down chart so that you see this, okay? And this should be going up and down if you've been logging time and completing tasks, moving them to done column. Cool. All right. So let's go ahead and turn off our sound here, and we'll get back to it because I think that's been 5 minutes. Yep. Oh, it's been 10. My apologies, everyone. Okay. So let's talk about post-processing. I don't want to talk about P3 until Wednesday because that is when P2 ends. However, let's talk about post-processing. So post-processing is the idea that your game is going to spend all this effort computing a final frame, right? It could be this right here. In fact, let's go ahead and play the game real quick. It could be this. Boing, right? But, you know, we can take this image, right? So your entire game essentially takes your game objects, it takes their materials, it takes everything in your game, and it turns it into a bitmap. It turns it into a 2D array of RGB values, and there you go. That is your buffer. And it shows that to the screen. Well, the idea with post-processing is that post render, post the render, after everything is drawn, we want to do something with those pixels. We want to mess with them. We want to add some cool image effects. If we're underwater, we want it to go, oh, woo, woo, right? If it's the early morning, we want to add this bloom so that light bleeds over the hills and looks almost fantasy-like, right? And so that's what we can do. Post-processing is when you choose to do that, okay? So let's go ahead and let's get to 1920 by 1080. There we go. What we're going to do is we're going to add post-processing to this game right here. So it looks a little bit unique and different. Let's go ahead. The first thing you'll need to do when your own project, and not in this one since I've already done it, but what you need to do is you need to open up the package manager, because the stuff you need, the components you need to get this working quickly, is not in the project. So what we'll do is we'll go to the package manager. This is a kind of an interesting place that you may not have used before, where you can look and see what kind of technology is out there that we can just use. It's currently refreshing packages. It is going to the internet, and it is trying to find stuff. Come on, it's taking a while. All right. So when you start, you don't see that many packages because these are all the packages that are currently in your game. So this is this can get you, and if you search for something, then you won't find anything. However, if you go in, you say, hey, I want to look at the Unity registry of packages, you'll see, wow, okay, we got a lot of packages. That's great. One of the packages that you can find is the post-processing package, right? And so you can find the post-processing package right here, and you can install it. You can update it. You can do all that stuff, all right? Cool. So now you've got it in your game. However, how can you start using it? Well, post-processing has a lot to do with the camera. So we need to find our camera, and there it is. We found it. And what we need to do is we need to add something called a post-processing layer and a post-processing volume, okay? I don't use this much at all, but the way I understand it is that the post-processing volume is essentially an area, right, a volume area. It's like a big block where if your camera is inside of it, the post-processing layer will execute. Okay, so let's actually make sure this is the case. Post-processing volume. Okay, what volume is it? It's always going to be on our camera, and it's always going to be global. Let's make it is global. There we go. And the post-processing layer, we've got that too. So there we go. I think actually it's the opposite. That's kind of unintuitive. The post-processing layer controls what camera is going to be activated and where. I'm not sure about that though. Anyway, it's okay. I can get you some more information on Piazza if necessary later. So what we'll do is we'll say, hey, what layer of objects should have post-processing execute on them? Everything should, okay? Which includes the camera. It will complain about this, but you can specify it just down to a camera layer or something later. So we'll create a new post-processing profile, okay? Oh, you might not be able to see very well because I am in the way. Let me go ahead and turn myself off here. There we go. We need to bring this. I'm just going to move because we still need to have the camera. The webcam caption. Okay, so let's go ahead and create a new post-processing profile. The profile is essentially it's just an asset. If we go to it, that allows us to put different effects on. Okay, so yeah, let's just make sure this is all working. And let's create a really big grain effect, okay? We'll turn this grain effect on. It's going to be colored. It's going to be very intense. If you've watched an old film, you might know what film grain is. So let's play our game and make sure it's working. Can we see it? I don't really see it. I'm not sure if it's working or not. Let's make it really big. Oh, it is working. You see that? It's a little bit hard to see, so let's zoom in a little bit. Do you see? Look at on the white. You can see it very, very clearly here, okay? This is a film grain effect that I believe you used to see on older screens, in older recordings of movies. And so if you want that kind of effect, maybe you want to have your, a TV effect, right? Where you're looking, through a video camera, right? Because you've got a horror game or something going on. Then that would make a lot of sense to add that. Let's add another effect. Let's turn this off, though, actually. Okay, I want to talk to you about a really popular effect called bloom. Has anyone heard of bloom? So bloom is a pretty cool effect where it causes light to bleed. The Elder Scrolls series is kind of famous for overusing this. Elder Scrolls Oblivion in particular went a little bit ham with this, okay? So if you look at screenshots of this game, on occasion you'll see characters who just seem to like glow in this heavenly light, even though, you know, it's just a shirt, right? And other things might not glow as much too, so it looks a little bit uncanny. And you can also see that like people, oh my gosh, look at her down there. Oh, I'm blocking it. Look at her down there in that photo. Whoa, that is a lot of bloom, okay? So it is an effect that essentially takes light and bright colors and makes them bleed across where they actually are. It takes those pixels and it smears them to other parts of the screen, okay, of the final image. Let's go ahead and add some bloom, okay? Add some bloom. Once you've got bloom, you've really got that AAA feel to your game. We'll turn up all these settings on. We'll turn the intensity on. Yeah, oh yeah, look at that. I feel like I got something in my contacts when I see this screenshot right now. So, whoa, it's we've ascended truly. So this is a very powerful effect. It's something that you might use just sporadically. In fact, what you could do is as the game starts, you could have it be really high bloom, and then you could have it fade out like this, right? Into the level. That would be really cool, actually. Particularly if your game has like a heavenly motif, or like you're waking up or something. That might make sense. I guess we can even change the color of our bloom too. Ooh, all right. We're in the depths of hell now, I think. So you can do a lot of really interesting stuff with all this. What's diffusion? What is this? What's it gonna? Whoa. Oh, interesting. Wow, look at this. Now I feel like I'm in a computer. What if we change this to kind of the green? Oh, look at that. Look at that. That's really, really cool. Wow. Gosh, imagine like a rhythm game where it's like do, 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 where it's like going in and out, and it's coming in and out, different colors, different diffusion, do, 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 right? Okay, so I apologize, everyone. But this is the kind of thing that happens. You start playing with all these neat post-processing effects, these graphical effects, and you just start getting ideas. And effects that you think would do one thing, like bloom, can have much different effects when you take the parameters and you mess with them. So it is another explorative, iterative, creative process. You just got to add things, see what happens, and see what works. Okay, let's talk about. I don't think I'm going to be able to get depth of field to work, because Unity's depth of field just doesn't seem to work very often, for me at least. So let's go ahead and set this up though, because I have a screenshot that can demonstrate what it is. The depth of field is something that you see so much in the Dark Souls series. They heavily approve of this, and I really like its implementation and usage. In Dark Souls, you will very often see things in the background. It is a big world that has a lot of really notable landmarks in it. And so you'll often see something interesting in the background, but you're never quite able to study it, right? It's always blurred, right? Things that are far away, pixels that are rendered further away, have a blur effect applied to them, okay? And this can add an air of mystery, right? You can see something big and imposing and interesting in the background, but until you get closer, you can't truly investigate the way you want to. It kind of it just beckons you in, which is really, really cool. It also creates kind of a sense of scale, doesn't it? Wow, look at these mysterious things that I cannot understand yet. Anyway, let's see if we can get this going. I'm going to need to throw something further in the background, though. Let's get a really interesting object. Capsule. Yeah, all right. We got a capsule. Okay, so we need to position this. Oh my gosh, we're going to start lagging soon because I've got too many impact spheres. I'm not despawning. So we're going to make this fast. Let's go ahead and pause the game. We'll make this like a maybe 20 by 50 by 20. Is that too big? Is that gonna just look dumb? Okay, we got this pillar in the background. Look at that. All right. It doesn't have a whole lot of detail, so it might not be possible. We're gonna make this slightly more interesting. I'm gonna put a capsule inside of another capsule. We're gonna rotate it a little bit. No, I can't tell. Let's do it, rotate it this way. Can't tell, let's rotate it this way. There we go. Okay, so that's kind of an interesting shape. It has a little bit more detail now. Maybe we can get it to appear in the depth of field. So where is our profile? Where did that profile go? There it is. I think it's this one? Yeah, yeah it is. Okay, so we'll load this up. Let's get some depth of field going. Depth of field. Wait, are we using this one? I apologize. Let's go to the camera. This is the one it's using. I think it was using the other one. That's right, it was. Okay, so we'll turn on depth of field. Focus distance is going to be 10. Aperture, focal length. I'm not a... Hold on a second. Can we adjust this? Focal distance. Oh, hey, it works. Okay. However, okay. So you can see it's a little bit difficult to see, but the foreground is looking a lot more clear than the background, right? And I think as we move this capsule back, we'll see this even more pronounced. Should be able to move this back, yeah, right? So I guess it's kind of a subtle effect, at least in this case. But if you look closely, you can see that the foreground, right, where our gameplay is taking place, is kind of crisp. And the background, however, has a blur applied to its edges. It's not super obvious, but it's something you can use, particularly if you have a game with a larger and connected world. A lot of us are making puzzle games and games where you warp into a tiny room. If you want to build kind of a connected world where you solve a puzzle and you walk through it to get to the next puzzle, then this could be a really effective post-processing technique to use. Okay, so let's go ahead and keep going. There's another 1 or 2 effects I want to show you. Get rid of that. Yep. And let's pause it. And I want to show you a vignette. Okay, let's try vignette. And this is something that can be kind of cool, particularly if you're making a horror game or a game where you want the player to feel claustrophobic or cold or damaged, right? As in hurt, like you took damage. So let's go ahead and get a vignette going, and I think it's right here. Yep, we got it right here. We'll turn it all on. We'll make it big. There we go. You can see it now. It's kind of hard to tell on the black background, so let's go ahead and go to our camera real quick. We'll get rid of the black background. We'll turn it into a. Let's just show the ugly skybox for now. There we go. Okay, so you can notice there's a little bit of a kind of a dark feeling, a sinister feeling to this screenshot already. And the reason is we have turned on a vignette that is putting this black shading at the edges of the screen. And we can make that much more obvious if we do this, right? It's almost like your eye is closing. All right, so oftentimes games will use something like this if it is a horror game and they want to make you feel a little bit sinister or claustrophobic without being too obvious about it. It's kind of it can be a subtle effect. We can also do things where we make it, not smooth at all. Let's take the roundness away and make this like a tube TV. We'll take the roundness all the way down, we'll bring it in, and now we've got like a film shot, right? This feels kind of old-timey if we start to... If we combine this with the grain, then we got this. We're going to have this really intense, like early Hollywood feel to it, right? Anyway, so that's kind of a cool effect. I believe one final thing I might want to show you is motion blur, because we do have some stuff moving, although I often can't get this one to work. Whoa, that was powerful, wasn't it? Let's get this going, because it seems to have turned off. What's gonna create a really good smear for us? Does anyone know? Let's see. Yeah, I don't think. I think Unity's motion blur doesn't work very well. Play around with the parameters. We're really not getting much of anything, are we? Oh, that's disappointing. There are third-party motion blurs, and you can implement one by yourself pretty easily in a few lectures when we show you how to write image shaders. But anyway, so these are a lot of different little effects, and you can experiment with them, and you can get a lot of interesting impact by combining these and tweaking these. Use vignette. So we created this cool little effect with the vignette, right? However, how does every first-person game tell you that you have taken damage? Let's make it a little bit softer, and let's bring it out here. Roundness, it's round. It's going to be smooth, very smooth. We're going to bring it back in intensity, right? How does every first-person shooter or first-person game show you that you've taken damage? They go, ooh, 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 right? And even other games that are not first-person will do something like this to help you understand that you're in danger, right? One thing I want to show you. So these techniques are used all the time in AAA and in professional indie games as well. Where is the Final Fantasy example? Where's the final? Here we go. So here's an example I was playing last semester on Google Stadia, actually, of Final Fantasy 15, okay? This is a moment in the game when you are going into this power plant. So you're standing outside the power plant where the lighting is kind of just natural and kind of normal. I think it's at night right now. And you look inside the power plant, and it's pretty clear, like, okay, this power plant clearly has some pretty good lighting, and it has this warm coloring, but not too warm, right? So it looks like a pretty standard, inside of a well-lit facility, right? Okay, well, as you walk into this facility, the post-processing that is currently being done globally on your camera is going to change massively. You'll be able to spot the difference. Let's take a look. So we walk inside, well lit. Oh my gosh. This has suddenly become the most sinister factory ever. We walk outside and it's well lit. It looks kind of normal. Nothing particularly spooky about it looking from the outside in. But you walk in and oh my gosh, the tone of this area just changes, like shockingly, right? Suddenly you feel like you're deep in the bowels of the earth and you found this sinister facility full of fire and brimstone, right? And so, if you become an artist on a project or a technical artist, you will be implementing these kinds of changes to try and get exactly that feeling right. So hopefully you make it a little bit more gradual than this so that doesn't stand out so much, all right? Anyway, there are just a handful of things that I want to talk to you about today still. Elements of professionalism. These are certain things that you will be required to have on your Project 3 about midway through it, okay? So while you're thinking about these different graphical and aesthetic effects that can make games look so much more interesting and unique and professional, here are some things that you will have to implement eventually. So start thinking about how you might do it, okay? The first one here is a screen transition. So right now, if you use the, scene manager.load scene function, and you almost certainly did for your Project 1, what happens is the game just kind of, hey, you're playing, you got one scene going on, and then boom, second scene, right? It is very, very jarring. However, most games, even games as early as like the 90s, the Sega Genesis version of Aladdin has a really cool scene transition. We're doing this kind of thing, right? So you're on the title screen, you press start, fade to black, Scarab comes in, a cool plot element from the Aladdin story and movie, right? And then it goes out, and then it fades back in to the tutorial screen, right? So they're using fades, they're using this really cool transition that happens whenever you fade, and it's really, really neat. Cuphead is another example, right? This is a kind of it has an old-timey cartoon theme, right? And old-timey cartoons very often ended with the circle transition, right? Where you fade in and out in the shape of a circle. And so you can do this. In fact, we'll be showing you how to do this in a few days during our screen shader lecture. Essentially, you just discard. You just draw a black pixel based on some sort of center and the radius value that you currently have from some point on the image. So it's not too bad. Hat in Time has a few different, like they went kind of crazy with the transitions. So just kind of a uniform fade from black to image, right? And then they're going to do a blink fade where they bring in the bottom and top bars, and then they do a silhouette fade where it's sort of like the circle, right? The Cuphead circle going in and out, but they actually use an image instead of a circle in the shape of the main character's profile. So it's pretty cool. Another really cool thing that you've already heard about, and something that you should try and do, especially if you have a 2D game, even on your P2, is parallax, right? Has anyone played this game, Owlboy? So this is a 2D game that was worked on for 10 years, famously, and it has this really open feeling tone to it, right? It has these environments where you really you can feel breath of the air, right? There's just so much of it. And the reason it feels so deep and so open and so large and expansive is because of the parallax, right? And it's not just the parallax, the idea that something that is further from the camera, even though it's not, of course, it's a 2D game, something that's further from the camera should move slower when your camera moves. They also use the idea of color palettes to help sell you on the fact that something's far away. If you go onto the top of a large hill, if you go up a mountain, if you look at something super far away on just a normal day, no unique weather or anything, you'll notice that things that are far away tend to get a blue tint to them, kind of a blue-white tint to them. They fade. Their color fades because things in the atmosphere are coloring what you see, right? And there's more atmosphere between you and whatever you're looking at when it's far away. So by kind of taking their color palette and fading it for objects that are far away, they really sell that effect that these are far away objects, right? They also get the additional effect of it's very obvious what is part of the gameplay geometry, as in things that you can stand on, walls that you can't go through. It's very obvious because the things you can jump on have like a vibrant color palette, not faded at all, and the things that are in the background do. So very effective. Juicy, smooth-moving cameras, right? This is something that's very useful. Watch this. Hat in Time. You walk up to a tutorial trigger the tutorial, cutscene happens, the camera kind of slowly moves up, and then it moves back to give you back your gameplay control, right, of it. So it's very useful. Toy Story 2 for the PlayStation and Nintendo 64 had a really cool character select where essentially they did this. The character select, whenever you move left or right, the camera will actually show you a new location where that level is going to take place, right? And it just smoothly moves through all of them. If you mash and go through the stage select super fast, the camera will take you through parts of the world you never see normally, which is super cool. You get to see the entire world. Lack of camera jitter. This is something you might notice in your games. When you're playing your game, you might notice that this thing in the center of your screen that your camera's following seems to like jitter back and forth, and it's very frustrating, right? It will hurt your eyes if you look too closely at this in your game. This can be fixed largely, right, by making a few easy changes, okay? So there is the rigidbody.interpolate checkbox. You can click on your rigid body. What this does is, one of the issues is in Unity, the rendering loop is desynchronized from the physics loop, okay? That's why we have an update and a fixed update. This is kind of nasty because you'll get that jitter if you happen to have a rendering object like a camera following around a physics object, right? Because the physics object will be moving at different times that the camera's trying to render it. So by clicking the checkbox, where is it? By clicking the interpolation property on your rigid body, or I don't think it's a checkbox, it's a few options. What Unity will do is it will kind of interpolate the physics position so that it will render it properly and smoothly whenever it renders. And another thing that you can do is, I believe you need to have the main camera. I think it should probably move not in update but in late update. So this might be inaccurate. And the main camera should move, its movement should be multiplied by time.delta time so that the frame rate can't cause it to jitter, you know? And you should get this pretty nice effect where it follows perfectly, it's stable, it doesn't look like this, right? Anyway, another thing you'll want to start thinking about are color palettes. So if you go to the Google homepage, you'll notice that it just looks great, right? It just weirdly looks really good and satisfying. You'll notice if you actually analyze what colors are being used here, that this Google logo uses blue, but not pure blue. It uses red, but not pure red. It uses yellow, but not pure yellow, and likewise with green, okay? What's interesting is that I believe this logo, it is using different hues, but it's using the same saturation and the same brightness. I'm not entirely sure if that's the case, but if you haven't heard of hue, saturation, and brightness, usually we think of colors in terms of RGB, right, as engineers. Artists tend to think of colors in terms of hue, saturation, and brightness, or some other schemes. And hue is the kind of is it blue, is it green, is it red, is it yellow, right? Saturation and brightness then relate to how bright or faded does the color show up as, okay? As it turns out, you can usually create pretty cool color palettes by changing one of those three things, hue, saturation, or brightness, and causing the other two to be locked and the same between these. There are plenty of tools out there. Color palette generator. There are tools out there that will do this for you and do a pretty decent job of it too. Colors, coolers. Let's take a look. Right, these tools will give you a set of colors that hopefully will look very good together if you limit yourself to only using them in the game, okay? So we'll start the generator. Come on, this is very slow. I'm not sure why it's this slow. It is not very difficult to calculate palettes. Okay. So these colors don't look half bad with each other, but we can press spacebar. Ooh, that looks pretty nice, right? Kind of bold color choices, but they're all fairly bold, so it's going to work out pretty well. This is more of a muted and faded batch of colors, maybe aside from these two. This is a very cold color palette. Maybe we can find a warm one. Yeah, this one's a little bit warmer. This one's very, very cold as well. This one's much more kind of a burnt, kind of desert style color palette, right? You might get a lot of mileage out of this if you have a setting that is in the Wild West, for instance, or a warm and hot setting. Anyway, so here's the thing, right? It might seem a little bit odd that your engineering course is going over all of these different topics. However, remember, your objective as an engineer is to build systems that have the impact you want, okay? So thinking about things like art, okay? Color palettes. How can we make sure that we have a system of we will only use these colors, right? This is important stuff. And if we want to build systems that work in the real world, surrounded by many different disciplines, having impact on a diverse set of people and skills, then we need to understand those around us, okay? We need to understand other disciplines and how we can have the most impact possible, okay? So we will interact with those disciplines. Another thing that you'll eventually need to have for your Project 3 is audio and sound. One of the best things that you can do to make your game juicy, as we heard from that video we watched a few days ago, audio and sound can make a game feel incredibly satisfying. That horror game that I gave you earlier on, it's kind of neat in that if you die, the audio system breaks. Like when you shoot the gun, it no longer makes a sound. However, play it, right? Refresh the page, play it, and pop the gun. It has a satisfying pop to it. It just sounds fantastic. It feels great to pop that gun, right? Hold it up with the right mouse button and left trigger to pull the trigger. Left mouse click to pull the trigger. And when you die, you lose that sound, and the game just kind of feels flat, right? It feels muted. It loses all of its energy. It still has the background music, but not the sound effects. And so the value of those sound effects reveal themselves. Okay, so I want to talk briefly about next time, and then we'll go. So next time, you have your P2 goal due, okay? And then I believe it's a week later, no, it's 5 days later, you will be beginning your final project in this course, if you can believe it or not. On Wednesday, you will also be able to start registering your team for Project 3, okay? So please, do some looking, if you can, into your Project 3 teammates. Otherwise, I will match you up automatically. You'll have a random team assigned, which can work out very well. Also, we haven't yet decided if it's going to be 4 or 5. I think it's going to be team sizes of 4. We went with team sizes of 5 last semester when we actually had 2 sections, so we had a lot more students. And the only way to possibly grade everyone in a reasonable amount of time was to go with teams of 5. We'll probably go with teams of 4 because we only have, 70 students, and that'll work out pretty well, okay? So please count on teams of 4, and otherwise, you'll have that 5-day break. We'll start talking about things like SIMD programming, I believe, on Wednesday. And we'll also show you some examples of some really successful P3 games, too, on Wednesday, okay? All right, everyone, I'll stick around for about 10 minutes or so. Otherwise, have a fantastic, safe, and healthy early start to this week, and we will see you on Wednesday. I'll throw some music back on. Let me know if you have any questions, team. And more importantly, maybe, let me know if you recognize this fantastic song from this fantastic series. You're welcome. Yep. You got it, Novi Cat. It's Danganronpa. Oh, yes, thank you, Foxkilla. Yeah, so that is definitely a unique new approach this time. So we're looking for feedback. As it is my impression thus far, and I don't have any official word on this, but it's my impression thus far that we're going to have another remote semester next time. So, yeah, I've lost my music. What happened? What happened? Did I lose all of my internet or just YouTube? Oh, I can't believe it. Ugh. And we lost our place, too. Well, that's a shame. We're going to have to listen to another fantastic track from another pretty cool game. See you, Ish. Good luck with your PC build. Okay, so for P2 Gold Spike, I didn't start using Jira or working on my project until the weekend because I had to catch up on project assignments for other classes, which need a break after P1. Will I get marked down in project management P2? Okay. I'll turn it down a little bit. So, you tend to only get dinged on P2 project management if you bunch up literally all of your tasks in the last 2 days. So, you know, we understand that you might want to take a break, and you might want to have a few days off where you don't do any work on the project. That makes sense. But you know, yeah, get started. I think you'll probably be okay. I think that P2 milestones are only on Wednesday, so that would give you, 3 days or so to put in work. So that's probably not going to get dinged, even though it might look a little bit strange on your burn down. Yeah, this is Katamari Damacy. You can see on the page here. Okay, so how would you suggest holding global values that persist in between level loads? Like that's very literally what we do with static. So when you load a new scene, you also unload the current scene that you were in. That involves destroying every game object instance in your scene. Now, if you're storing variables in a game object instance, in your hierarchy, like you can see it in your hierarchy, then it's going to be destroyed. You're going to lose that data. Static data is not in the scene. It is just in the overall program itself. So that data will not be destroyed when you go from scene to scene. And that might be something you want or don't want. It is a potential source of bugs, but if you need to persist data long term, then it is often done via static variables, static data structures. If you need to persist a game object, you use the don't destroy on load function. And that will make sure the game object is not destroyed when you transition scenes. It will be around forever. To making the player a child platform, how would you say this goes to thing? I'm making a platformer for my P2 game and having some issues with my moving platforms. The player doesn't move in sync with platforms, which is causing some issues with jumps. Yep. I tried making the player a child of the platform. Ooh. When they were on it, but this broke my player controls. Is there another good way to get it? Okay, so what I would do, one of the clumsy ways to do it is you can just increase the friction on your player object and on your platform. So when your platform moves underneath your player, hopefully your physics system will say, hey, there was a little bit of friction generated because these two surfaces were in contact and they moved. And if you have enough friction, hopefully you'll get a little bit of movement. But it doesn't tend to work that well, in my opinion. What I usually do is I will detect what object I am on top of. So for instance, I'll have a component that is always raycasting downward, and if it detects something, it will also track whether or not it has moved since the last frame. So it will store where it was last frame, it'll store where it is this frame, and it will take that delta and it will apply it to my player. So if you're standing on an object that moves, the player will move themselves to keep up with the platform that they're standing on. That's what I usually do. It works out okay. I think there's some edge cases where it doesn't work very well, but yeah, that's what I recommend. I accidentally thought Project 2 management went with P2 Gold and realized that Project 2 management also been done for P2 Gold Spike. Okay. Due date was later. When I found out today, I added the sprint for P2 Gold Spike immediately with the tasks that I completed and my time estimates. How long I took them, I also added... What else can I do? So what'll happen is you just go through the assignment spec, make sure that you've done everything to the tasks that you wanted to have. Make sure each task has a time estimate. Make sure that if the task is done, you did log some time against it. And that's what all you can really do. We're going to see that you created all these tasks at the last moment, which is going to look really weird, and you'll get dinged. You won't get dinged for that unless there's another issue. As we said at the beginning of this lecture, or during the halfway point, during the break, if you mess up one category of thing on your project management, that doesn't cause you to lose any points. If you mess up 2 or more, then you will lose points. So adding all your tasks late would be considered a one category messed up, essentially. Okay, I'm out of here, team. Thank you so much for hanging out, and I hope this lecture was useful. I hope it is eventually useful if you come back and watch the recording, maybe. Otherwise, I hope you have a fantastic week, and we will see you on Wednesday. Take care.